Good morning, class. Today we'll be introducing to you electrostatics. Now, in electrostatics, we'll be focusing on charges and how much force they exert on each other and how do they act when they
What to get?
are together, maybe.
Okay, sir.
Now, charges have signs. Those signs just determine how they will be repelling or they will be attracting each other. So tell me, student, when you see these signs, the positive signs, what comes to your mind?
As we studied in the previous grade, sir, I know that like charges, they repel, and unlike charges, they attract.
Good, thanks. Now, yes, as he said, the charges with same signs do repel each other due to their electric fields not colliding or not mixing. What's the cause of that is charges move from the positive to the negative charge. I hope that's clear.
Yes, sir.
If the charges are both positive, the other thing to note is that electric field lines do not cross. Not ever, not at any time. They do not cross. So when you're drawing the structure, make sure there's no intersections of the electric field. So yeah.
Right, sir.
So the reason why they repel is because this is a positive, this is a positive. So when they come together, the positive cannot mix with another positive. As I said, the charges only move from positive
To negatives.
negative charge.
Okay, sir. So let us say now we have two negative charges. Will they still respect that electric field as the positive ones?
Okay, thanks for that question. That's maybe many students are struggling with that, so I will answer it right now. So, two negative charges also act the same way as the two positive charges, but what's different in them? The difference in those two charges is that now they also repel each other, né?
Yes.
But what you have to note is that now the lines are pointing into them.
Okay, sir.
They point towards them. Yeah? So meaning, as I said, it only moves from positive to negative,
Yes.
not the other way around.
Okay.
So in here, they are moving. So in this is accepting. Let's say it says accepting protons, and this one is accepting protons. They both accepting protons, so there's no sender, so they will repel each other. This one is it's sending proton. This one is receiving receiver. They accept. That's the difference in. So you learn how.
Understood, sir.
You understand more. We're getting to maybe how much forces or how much electric field strength is applied when doing this. So electric field strength depends solely on the amount and the distance between
The two charges.
two charges.
Okay.
So in order for them to attract or repel each other, they have to have some certain distance in them. And there is a minimum and there is a maximum distance between the charges to attract. How will you determine that? Is by being given maybe two charges with positive, and let's say let's say both charges were given maybe, let's say 2, let's just say 2, and then let's say 3, yeah. And the distance between them is maybe 4 centimeters. Then also being given the same charges. The same charges, but the distance between them is maybe let's say 2, yeah.
Oh, sorry, sir. Can I ask a question? So, like, if the distance is different, like, how does that affect our electrostatic force?
Thanks for that question. I was getting there, sir. So yeah, let me give you something to note first. In mind, just note there is this formula. This formula is for electric force, electrostatic force. Now, with K being our constant, let's just say it's our constant. Q1 being the charges, the Q's being the charges. Q1 will be the charge you name for yourself. Let's say this one is Q1, and this one will be Q2. That's obvious. And this will be the distance between the charges.
Okay.
I hope that's simple.
Yes.
So you were asking how will the distance affect the electrostatic force?
Yeah, the force.
So coming back to your answer. Now, saying the formula, this is the inverse of this one.
Okay.
So when you hinder with this, if you increase the distance, that means you are decreasing the electrostatic force.
Okay. Okay.
And vice versa.
All right.
And if charges change, let's say you put different charges with different magnitudes, on increasing charge strength, you also increase the force acting upon the charges. I hope that's clear now.
That's clear, sir.
Oh, thank you, sir. Now, continuing to what you were saying, for example, as I said, these charges they are the same. This also Q1, this also Q2. Now, the distance between these two is only the distance that is handled with. So we'll see what the force will be after these two examples. Now, let's calculate the force for the first example. Okay, now force for number 1 is K.
Well, sorry to say, our K it's 8.99 times 10 to the power 9.
Thank you, sir. Thank you so much. It's 8.99 times 10
to the power 9.
The power negative 9 or
9, positive 9, sir.
positive 9. So that's our K, sir. Thank you very much. K into, this is a constant, by the way, yeah?
Okay.
So Q1 will be our 2, and Q2 will be 3 over the distance for the first example.
Okay, it's 4.
Is 4. So 4, don't forget the square.
So is the distance in centimeters or maybe meters? What are the units of the distance?
Okay, the units of the distance are dependent on the question.
Okay, sir. Yes.
So they
understood.
Can be centimeters, meters, or
okay.
any unit. So let's just use centimeters in this scenario.
Okay.
Just as an example, okay? Now let's just calculate 2. Okay, let's say K 6 over 16, which is K will be 3 over 8. Now we can press that in the calculator.
Okay, let's check that, sir. Let's check that. Okay, it's 1.99 times 10 to the power 3.
You multiply it by the 8.
Yeah, multiplied by the k, yeah. It's 1.99
1.99
times 10 to the power 8.
10 to the power 8.
Mm-hmm.
Okay, let's see for the second example. Now, example 2 is this one. So, in example 2, we only hinder with the distance. So, example 2 will be k into 2, 3 over 2 squared. Seeing the distance is 2 now.
Okay.
Okay. So please just press it in the calculator.
Yeah. That has to be 2.99 times 10 to the power 8.
2.99 times 10 to the power 8. Hope you written this down because